North Atlantic, 3:15 hours, March 17, 1943. The sea was black and endless, a heaving, metallic monster under a moonless sky. Wind screamed across the frozen deck of U-221 as spray lashed against the conning tower. Inside the cramped pressure hull, red emergency lights painted sweating faces. The men of the Kriegsmarine's elite wolfpack, Sea Wolf, were silent now, ears straining to every metallic creak. Moments ago, they had been hunters. Now, they were the hunted. The sonar operator's headphones hissed with static, and then came the faint ping. Once, twice, then faster. The British and Americans had always used sonar, but this was different. The rhythm was impossibly precise, as if the surface ships above could see them. The captain barked an order. The U-boat dove deeper. Compressed air hissed. The hull groaned like an old ship cracking under ice. The crew waited, holding their breath. Then came the explosion, not above them, not behind them, but directly ahead. The shockwave slammed through the boat like a hammer. Lights flickered. Men were thrown from bunks. Wie ist das möglich? Someone gasped. How could they know exactly where they were? What the Germans didn't yet understand was that the happy time, their golden era of dominance beneath the waves, was over. Only 2 years earlier. In 1941, Admiral Karl Donitz's U-boats had prowled the Atlantic with near impunity. German submarines sank merchant convoys faster than Britain could replace them. The Allies called it the Black Gap, the stretch of mid-Atlantic where no aircraft could patrol and no escort could reach. Here, the wolfpacks reigned supreme. A single U-boat could cripple an entire convoy, torpedoes striking like fangs in the night. Oil tankers burned across the horizon. Over 1,200 Allied ships went down during this reign of terror. Sailors whispered that the ocean itself belonged to Donitz. But by early 1943, something had changed. Reports flooded Berlin. Convoys that should have been easy prey were suddenly vanishing from sight before contact. Depth charges, once imprecise thunderbolts hurled blindly into the sea, now struck with eerie accuracy. Entire wolf packs disappeared without a trace. Donitz himself called it the crisis of the U-boat war. His officers, veterans of hundreds of patrols, were shaken. They always know where we are, one commander told him. They always know. On the surface, the cause was invisible. To the men below, it felt like black magic. But above the waves, science and industry were rewriting the laws of underwater warfare. British and American engineers had quietly perfected a new form of detection, one that could not only hear a U-boat but also track its movement in 3 dimensions. It wasn't sonar as the Germans knew it. It was something deadlier, something coordinated across ships, aircraft, and shore-based intelligence. The Allies had turned the Atlantic into a giant, living sensor. Still, in early 1943, the Germans believed they were fighting the same war as before. When U-221 slipped out of Lorient harbor under cover of darkness, her crew sang the old Kriegsmarine hymns and drank coffee laced with rum. They still thought of the Atlantic as theirs. Their commander, Captain Lieutenant Hans Hartwig Troher, was an ace with over 50,000 tons of shipping sunk. His men called him Der Jäger, the hunter. That night, as they cruised west of Ireland, he smiled beneath his cap and said, "England will starve before we do." But that confidence evaporated within hours. Their first contact came at midnight. A convoy codenamed HX-229. Dozens of merchant ships, escorted by destroyers. Textbook target. Troher ordered silent running, closed in to firing range, and fired 2 torpedoes. Both hit. Flames erupted across the horizon. The crew cheered. The hunter had struck again. Yet seconds later, the sonar operator froze. The ping returned, not one, but many. Dozens. It was as if every ship in the convoy suddenly turned toward them in unison. Troher ordered an emergency dive. As the U-boat descended, the sea came alive. Explosions detonated above them in perfect sequence, one after another, walking toward their position. The pattern was too precise to be random. The crew shouted prayers. One explosion knocked out their forward battery. Another cracked a fuel line. The submarine lurched violently as depth gauges shattered. "It's like they can see us," muttered the engineer, clutching his bleeding forehead. What none of them knew was that Allied escorts now carried a secret weapon, a revolutionary sonar system so accurate it could pinpoint a submarine's depth and angle in real time. Combined with improved depth charge settings and new aerial support from long-range Liberator bombers, it turned the Hunter's Ocean into a killing ground. The once invincible wolf packs were being slaughtered faster than they could be deployed. By March 1943, Donit's nightmare had come true. In a single week, 41 U-boats were lost. Crews who once returned as heroes were now vanishing into silence. The happy time, the era when U-boats ruled the Atlantic, had become the Black March. And still, the U-boat crews refused to believe it was luck or radar alone. There had to be something else, something deeper. How could the Allies always know their exact course, even when radio silence was maintained, even when decoys were deployed? The answer was hidden behind layers of secrecy in Allied command rooms, a fusion of code-breaking, technology, and precision manufacturing. In factories across America, new depth-charge detonators were being built with micrometer precision, capable of exploding at exact depths. Engineers at Western Electric and General Electric were refining acoustic sensors that could track the faintest propeller vibration. And in a quiet corner of Bletchley Park, cryptanalysts had cracked the U-boat Enigma cipher yet again, allowing convoys to avoid ambushes before they ever formed. But for the men aboard U-221, none of that mattered now. The hull groaned under pressure. Instruments failed. The captain whispered a single word: surface. The submarine rose slowly, desperately. Water poured through cracks. When the periscope broke the surface, what they saw wasn't a single destroyer. It was an entire hunter group, converging like vultures. Spotlights pierced the night. Shells screamed into the waves. Trohier gave one final order: prepare to abandon ship. Moments later, a direct hit split the conning tower. The U-boat vanished into the depths it once ruled. By dawn, the sea was quiet again. Only oil and debris floated on the surface. The convoy continued on its way, unaware that below them lay the wreck of one of Germany's most seasoned hunters. That day marked a turning point, one the Kriegsmarine refused to accept. Their ace submarines, their veteran captains, their reputation for invisibility, all were being erased by an enemy that seemed to know their every move before it happened. But what was the true secret behind that precision? How did Allied depth charges find their mark with such uncanny accuracy, as if guided by unseen hands? The answer would emerge in the next months, a technological revelation so advanced, so unexpected, that even German scientists could scarcely believe it. And it began with a single invention that changed underwater warfare forever. It started as a whisper in the laboratories and shipyards of Britain and America, a quiet revolution. Beneath the noise of war, engineers, not admirals, were about to decide the fate of the Atlantic. And the weapon they built would turn the ocean itself into a trap. The secret was called Hedgehog. To most sailors, the name sounded harmless, even comical. But this compact cluster of 24 steel projectiles would become the U-boat's worst nightmare. Unlike traditional depth charges that exploded at preset depths, often missing their targets by dozens of meters, the Hedgehog fired a spread of contact bombs ahead of a ship's bow, detonating only on impact. That meant silence before destruction. No warning, no thunder rolling through the depths, just a single, precise explosion that signaled the end of a submarine. The Americans didn't stop there. Alongside the Hedgehog came a new generation of ASDIC sonar, the Type 147B, which not only detected submarines but also measured their depth and course with pinpoint accuracy. In earlier years, sonar lost track the moment a destroyer passed over its target. Now, the Type 147B could see through that blind spot, continuously tracking as the ship attacked. The destroyer became both eye and sword, hunting with mechanical precision. Behind this leap in technology were engineers whose names rarely made the headlines. Men like Albert H. Taylor and Leo C. Young, pioneers of underwater acoustics, and Dr. Norman Cockcroft, who refined the Hedgehog's firing mechanism to detonate at the slightest touch. In the factories of Bath, Maine, and Liverpool, workers built thousands of launchers under conditions of secrecy so intense that many had no idea what their invention even did. When these new systems reached the Atlantic in early 1943, the results were immediate and terrifying. Convoy escorts that once dropped dozens of depth charges in hope now needed only one perfect strike. Destroyers like the USS Bowery and HMS Dianthus began recording confirmed kills with unprecedented speed. The crews noticed something eerie. Every explosion seemed perfectly timed and perfectly placed, as if the ocean itself had turned against the U-boats. But the true edge came not just from hardware. It came from coordination. In the dimly lit rooms of the Allied Black Chamber, intelligence officers fused sonar data, radar tracks, and decrypted radio signals into one unified picture. For the first time in naval history, warships, aircraft, and land-based command centers shared information in real time. This network, primitive by modern standards, was decades ahead of its time. It turned the Atlantic into a living grid of sensors, a prototype of what future generations would call network-centric warfare. And still, the Germans couldn't understand it. They blamed new explosives, supernatural luck, and even sabotage. Donitz ordered a series of investigations. Technical teams tested depth charge fragments and pressure hulls, convinced that the Allies had developed some kind of magnetic homing weapon. But the truth was simpler and far more devastating. The Allies had learned to see sound. Each U-boat emitted a signature, a kind of acoustic fingerprint. The hum of its diesel engines, the rhythm of its propeller blades, and even the faint vibrations of its hull under stress, all created a sonic identity. Allied operators trained for hours to distinguish one submarine from another just by ear. Some could even identify a specific captain by the pattern of his maneuvers. The hunter had become the hunted, not by luck, but by mathematics. March 1943. The Battle of the Atlantic reached its turning point. The massive convoy battles HX 229 and SC 122 unfolded over 5 brutal days. 40 U-boats attacked in coordinated waves, one of the largest wolfpack operations of the war. The weather was atrocious. Rain slashed the decks. Visibility dropped to zero. For a moment, it seemed the Germans might reclaim their glory. In the chaos, 17 Allied ships were sunk. But then, something changed. Allied escort groups, using the new 147B Sonar and Hedgehog launchers, counterattacked with surgical precision. In 1 hour, 5 U-boats were destroyed. The destroyer HMS Vedette scored 2 kills in a single pass. The corvette HMS Dianthus fired a Hedgehog salvo and reported an explosion so violent it broke the water's surface with debris and oil. The remaining U-boats tried to retreat, but air patrols from long-range B-24 Liberator bombers, newly equipped with Lee lights and radar altimeters, hunted them from above, driving them back into the trap. WWII dawn. The convoy was bloodied but intact. The wolfpack, Robgraph, had been annihilated. For the first time, the hunters fled. The ocean that once promised them power now offered only silence and fear. Donit's radio logs from this period were grim. Losses are intolerable. Morale is failing. Technology against us. The Kriegsmarine had entered a nightmare loop. Every improvement they made to stealth or communication was met by a faster Allied countermeasure. Engineers at the Kiel Naval Yard proposed new coatings to absorb sonar, but Allied scientists had already begun experimenting with variable frequency systems that nullified them. German depth gauges became unreliable under extreme pressure. Allied detonators, however, were precise down to a meter. What truly broke the back of the U-boat fleet wasn't just the weapons, but the speed of adaptation. American industry, with its near-infinite production capacity, flooded the Atlantic with upgraded destroyers, sonar arrays, and radar units. Every month, new technologies rolled off assembly lines at Bethlehem Steel and Western Electric. The Germans, by contrast, struggled to keep pace under Allied bombing. Their factories were in ruins. Their supply chains were collapsing. WWII late spring 1943, Donitz had no choice but to admit the truth. The ocean was lost. "We can no longer maintain the offensive," he wrote to the High Command. Of the 40 submarines deployed in the March offensive, nearly half never returned. Some vanished without a trace. No distress calls, no survivors. Families received only the dreaded phrase, "Lost at sea, cause unknown." Among U-boat crews, fear turned to superstition. Sailors whispered that the enemy could hear thoughts through the hull, that the sea itself betrayed them. Veterans began calling Allied destroyers the blind hunters, ships that somehow never missed. But those hunters were anything but blind. They were armed with data, coordination, and precision engineering, a trinity of modern warfare that had never been seen before. And yet, even as the Allies closed their grip, the true reason behind their impossible accuracy remained hidden from most of their own sailors. Only a handful of officers knew the full story, that their triumph wasn't just sonar or Hedgehog launchers, but something far more secret, buried deep within the halls of Bletchley Park and Arlington Hall, because every time a German submarine surfaced to send a weather report or convoy sighting, someone was listening. Someone already knew where they were. The end of the happy time wasn't caused by a new weapon alone. It was the product of invisible intelligence, a war fought in code, in circuits, and in silence. And as 1943 bled into 1944, that silent war would shift from defense to total domination, where technology and information fused into a weapon more powerful than any torpedo. The U-boats were no longer facing men. They were facing a machine that could think faster than they could hide. To be why the summer of 1943, the Atlantic had changed. What was once a graveyard of Allied tonnage had become a proving ground for technology, coordination, and human endurance. The Allies had achieved the impossible. They turned the world's largest ocean into a battlefield they could see in every direction. The hunters of 1940 were now the hunted, and the happy time, that golden age of German submarine dominance, was gone forever. In war rooms from London to Washington, maps that once bled red with sinking markers now showed long, unbroken lines of convoys moving safely to Britain. Supplies, tanks, and aircraft crossed the ocean unmolested. The steel arteries of democracy began to flow freely again. For the first time in years, Allied commanders could plan offensives without fearing that their lifeblood, oil, ammunition, food, would vanish beneath the waves. But for the men inside the submarines, the end came slowly, painfully. Each patrol grew longer, quieter, and more hopeless. The familiar sound of the sonar ping, once a distant echo, now meant death was minutes away. U-boat crews tried everything, diving deeper than ever before, shutting off engines to hide insolence, and even lying motionless on the seabed. But Allied sonar could now distinguish a submarine from a rock by the faint hum of its electrical systems. The ocean offered no refuge. In the logbooks of surviving German officers, despair replaced pride. Some captains reported hearing the propellers of destroyers circling above them for hours, sometimes days, before the fatal pattern of depth charges began. One described it as a slow execution carried out by ghosts. Another wrote simply, "The sea is no longer ours. It belongs to them now." The transformation wasn't luck. It was the result of relentless innovation. Allied scientists and engineers didn't rest after developing the Hedgehog or improved sonar. They kept pushing forward. Project Swordfish, an advanced radar system for patrol aircraft, extended detection range to nearly 20 miles, allowing planes to spot U-boats at night or through clouds. High-frequency direction finding, known as HFDUF, pinpointed the exact location of a radio signal within seconds. And behind it all, a secret group of mathematicians and cryptanalysts, working in silence at Bletchley Park, were reading German naval codes faster than donuts. Men could change them. Every U-boat that transmitted a message became a beacon. Within minutes, Allied command centers knew its approximate position, course, and likely target. Destroyers and bombers converged before the crew even realized they were being hunted. To the Germans, it seemed supernatural. How could the enemy appear so fast, so accurately? The truth was, they were already waiting. In April 1943, Admiral King of the U.S. Navy declared the Battle of the Atlantic essentially won. It was not arrogance, but calculation. Allied production now outpaced U-boat destruction by 10-1. In American shipyards, Liberty ships rolled off the assembly line every 3 days. Each one carried the promise of victory. Steel built faster than German torpedoes could sink it. War had become a contest of industry as much as courage, and in that contest, Germany never stood a chance. But victory came at a cost, one written not in tonnage, but in lives. Nearly 28,000 German submariners never returned from the sea. over 70% of all those who served. Theirs was one of the highest casualty rates of any branch in military history. For the Allied sailors who faced them, the trauma lingered too. Convoy duty meant endless cold, fear, and exhaustion. Some men broke under the pressure. Others drowned in silence when their ship was hit. Yet through that suffering emerged a new kind of warfare, one that fused human instinct with mechanical precision. When the war finally ended, the lessons of the Atlantic became the foundation of modern naval doctrine. Every navy in the world took note. The age of the lone submarine wolf was over. The era of networked warfare had begun. Sonar arrays became smarter, torpedoes faster, and aircraft deadlier. In the Cold War years that followed, the United States and Soviet Union built submarine fleets far beyond Donit's imagination. But both understood one truth carved from the bones of 1943: no vessel, no matter how stealthy, could survive without information supremacy. American engineers carried the spirit of the Atlantic into the digital age. The systems that once coordinated convoys evolved into early warning networks, satellite communications, and sonar grids stretching across the world's oceans. The algorithms that tracked U-boats would later help detect missiles and guide drones. The battle that ended the happy time didn't just secure shipping lanes. It rewired the way humans fought wars. And yet, amid the machines and mathematics, the heart of the story remained human. The machinists in Detroit who worked 16-hour shifts forging sonar casings. The women at Western Electric who soldered circuit boards under strict secrecy. The naval officers who stood on freezing decks, listening to the ping of sonar as if their lives depended on every echo. These were the unseen soldiers of the Atlantic, the quiet architects of victory. For Germany, the defeat at sea carried deep psychological scars. Donitz, once hailed as a naval genius, spent his final months of command watching his proud U-boat fleet dissolve into wreckage. Crews refused to sail. Boats remained tied to the docks for lack of fuel, parts, or willpower. The very ocean that had made Germany powerful now became a prison. In post-war interrogations, captured officers admitted that morale had collapsed completely. They had come to fear the sound of their own sonar, a reminder that somewhere out there, death was listening back. Historians would later debate whether the turning point came from radar, sonar, cryptography, or sheer industrial might. But those who were there, the men who lived through it, often gave a simpler answer. "We won," said one Allied commander, "because we learned faster." That was the quiet miracle of 1943, not the invention of one weapon, but the synchronization of thousands of minds across continents, all working toward a single goal: to make the ocean safe again. As peace returned to the Atlantic, the wrecks of hundreds of submarines remained below, silent tombs on the seabed. Each one marked a moment when technology overtook courage, when precision outmatched stealth. Divers who visit them today describe an eerie stillness, steel husks resting in eternal darkness, surrounded by the ghosts of those who believed they were invincible. The story of the happy time and its brutal end is more than a tale of ships and sonar. It is a story about the speed of change, how innovation, once unleashed, cannot be stopped. The ocean that once belonged to the hunter became the domain of the hunted, and from that transformation was born the blueprint of modern warfare. In the end, victory in the Atlantic wasn't just about weapons. It was about minds, the scientists, engineers, and sailors who turned data into survival and silence into power. And as the final U-boat slipped beneath the waves, the world learned a timeless truth of war. In the battle between courage and calculation, the ocean always sides with those who listen.